I'm Anil Kumar. Welcome to my series on geometry. Here's a brilliant question from one of our students who is preparing for SSC. Mr. Theo, thanks a lot for posting questions, and I hope its solution will help many others. I really want to appreciate all the members who are my subscribers and who are watching my videos to participate actively as they are doing to enhance the quality of our videos. Here is a method to solve this question based on geometry. We'll kind of give you a shortcut to provide the solution of this question. Let's read the question first. Circle with center at P is inscribed in a square whose area is 400 meters square. So this square is 400 meters square. All sides are equal. So 20 times 20, that means each side is 20 meters, right? So each side of this is 20 meters. Correct? So that is first thing which we have got. That is the circle with center P. Circle with center Q is inscribed in a right triangle. So this is a right triangle with hypotenuse of 25 meters. So this is 25 meters. Hypotenuse, clear? Okay. Square and the right triangle have a common side. So this is the common side of square and the right triangle. Find the distance PQ between the centers of the two inscribed circles as shown in the figure below. That's the question for you, right? Now to solve this question, what you need to know really is equal tangent theorem. So let me just put it in bold. What you need to know is equal tangent theorem. And this theorem helps to solve this particular question very easily. Otherwise, it is kind of complicated. Okay, now let's see how to apply this theorem to solve. Now, clearly from here, we can say that since the total length of a side is 20 and that is a circle, so this has to be 10, right? So this has to be 10. Now, that means this is also 10, right? This is also 10, correct? Okay, now, we need to find distance between P and Q. Let us say that this radius from here to this place is R. We don't know what this R is. We need to figure out what this R is, right? Okay. Now, looking into the right triangle right there, we know that this length here, let's write the sides. Let me start with this A, B, C, and D. It becomes easier. Let's call this point as E. Well, this is an important point for us. We'll call this as F, and we'll call this point as G. Okay. Now see. Since AB is 20 and the hypotenuse B is 25, we can find what AE is, right? So AE using Pythagorean theorem, so we know AE is basically equal to square root of this square, which is 25 square, minus AB square, which is 20 square, correct? So we can get what AE is. Okay, so that is square root of 625 minus 400, correct? Which is 225, which you know is 15. So we get this A to E as 15, correct? That is using Pythagorean theorem in the triangle ABE. That is the first step. Now, if this is R, then let's look into that position, right? These are also R, correct? Now, what you notice here is that from a point, we can consider 2 points. So from the point, let's say E, from the point E, E to G is actually equal to E to F. Why so? That is an external point and these are the two tangents. That is equal tangent theorem. So this is what is equal tangent theorem. You can solve many geometry problems using this theorem, right? So we know EG is equal to EF. Now what is EG equals to? Now this is R, that means A to G is R, right? So what is EG? EG will be equal to 15 minus R. This is R, right? 15 minus R. So we get that both of them are 15 minus R. Correct? So that means this side here is 15 minus R. So we get this EG equals to EF and both are equal to 15 minus R. Clear? Now let's look into the tangents from B. So from B to, let's call this point H. So from B to H should be equal to B to F. Why? Equal tangent theorem. From B, these are the two tangents, right? These are the two tangents. They are equal. Now clearly, BH is 20 minus R. Therefore, BF is also 20 minus R. So this side is 20 minus R. Do you see that? So from here, very clearly, what do you get? You get 20 minus R plus 15 minus R should be 25. Correct? We get 20 minus R plus 15 minus R should be 25. Correct? So we get 20 minus R plus 15 minus R is equal to 25. Now, so that is, we can take 25 on this side. So we get 20 plus 15 minus 25 equals to 2R. Now that is, when you take away this, you get 10. So 10 equals to 2R, or we get R is equal to 5. Is that clear? So we get R as 5. So we got one thing. And now, see what we are going to do. We need to find PQ. So we'll just extend this line. Do you see that part? So we know that this length here is 5. Since this is equal to R. Is that correct? This length is 5. Since that is equal to R. And we also know that from the midpoint, so let's call this point as K. Now K to G, let's write it here now. So K to G is basically equal to 10 plus R. 10 plus R. In this case, R is 5, so it is 10 plus 5, which is 15. So KG is 15, and let's call this point as L. And P to L is basically 10 minus R. It is 10 minus 5, which is 5. So if you look into the triangle, which is a right angle triangle, PLQ, now in this right angle triangle, hypotenuse is PQ, correct? So we can write down that PQ is equal to square root of PL square, which is 5 square, plus L2Q square, which is 15 square. Square root. Perfect. So, which is 25 plus 225 square root. So, PQ is square root of 250, or 25 square root is 5 square root 10. Units are in meters. So we get our answer as PQ is equal to 5 square root 10. Does make sense to you? So we've done a lot of work here. However, this is pretty short if you know the concepts, right? So when you draw or look at this, then the first step here is that using equal tangent theorem from points E and B, we know that EF is 15 minus R, right? And BF is 20 minus R. But it is given that both these combined is 25. That gives us the value of R as 5. Now this is 5, that is 5. So kg is 10 plus 5, 15, and PL is 5, hypotenuse, 5 square plus 15 square, square root, gives us the distance between the two centers. Is that clear to you? So that is how we are going to solve this particular question. Let me once again thank all the participants in our group to post beautiful questions and provide solutions. And I hope it is going to help many others. It's a humble request to all to join our YouTube channel and the WhatsApp group. If you have questions, feel free to post them. Thanks for your time and all the best.